All right, so let's try this one. Now we're going to draw the influence line for the shear at C. So to find the shear at C, what do we normally do? If I ask you to find the shear at C for anything, what would you do? You would cut the structure at C, and now you need to decide whether you're going to work the left side or the right side. I don't really see any advantage. While the left side is a pin, right side is pretty much a pin too. So you guys pick left or right. Left. We'll go left. So if we go left, what do I need? I need the reaction at AY. So let's do that first. So I've got to find the influence line for AY to get started. So if I do that problem, again, I'll draw the structure. There's my unit load at some distance x. And then at AY, there's my reaction, and I'll assume BY is here. And I want to find AY as the unit load moves across the structure. How best to do that? Some moments at B. So let's balance, make sure we're in equilibrium by summing the moments at B. And when I do that about B, this 1 is going to create positive moment. And what's the distance between here and B? Well, the total distance of the structure is 12. So it'd be 12 minus x. And then I have AY, which is creating negative moment. And what's its moment arm? 12. So therefore, if I solve for AY, I get 1 minus x over 12. So that says when x is 0, which means my unit load is right here above A, what's the reaction at A? 1. And as I move to the right, let's say all the way over to B, where x is 12, the reaction is 0. So the reaction is maximum when I'm right over the top of it, and it decreases linearly as I move to B to 0. That's basically the influence line for the reaction at A. Now we want C. So now I'm going to come down here, and I'm going to cut the structure at 3 feet. I already know my reaction at A. What is it? 1 minus x over 12. And then internally, I want the shear at C. I know positive shear is down. Now, this is from 0 to 3, so I'll write this one, x equal 0 to 3. And then somewhere on here will be my unit load at some distance x. Everybody see that? So how do I find the shear at C? Some forces in the y. So we'll assume up is positive, and if you sum forces in the y direction, make sure it's in equilibrium, what do you get? I'm assuming up is positive, so I've got my reaction at A up, which is 1 minus x over 12. I've got this down, minus 1, and I've got my shear down. So I solve for the shear at C, and what do I get? Negative x over 12. Remember, this is only valid between 0 and 3. So when my unit load is between 3 and 12, I can use the same free body. I still have the reaction. That hasn't changed. 1 minus x over 12. I still have the same shear at C. But what's changed? the unit load is not between 0 and 3. It's over here, between 3 and 12. So it's not on this free body. So what do? I can find the shear. And to do that, I'll just sum forces again in the y direction. This time I have this one acting up. That's 1 minus x over 12. And then the shear at C acting down. So I can solve for the shear at C. It's 1 minus x over 12. And that's good from 3 to 12. Now all I do is plot that. So now my shear at C as a function of the position of the unit load on the beam. And I'll go ahead and divvy that up. So this is the 3. That's 3. And then this is 12. So from 0 to 3, I plot this. So at x equals 0, it is 0. At x equals 3, what is it? It's negative. And 3/12 is 1/4. Everybody see that? And then from 3 to 12, I plot this equation. What is the value at x equals 3? It's 3/4. And then it drops linearly. When I get to 12, what is it? 0. So there's my plot. Everybody see that? Interesting thing to note here is what is the change in shear at C as you go from the left side of C to the right side of C? 1. It'll always be that.
So that, oh sorry.
Go ahead.
The little distance to the negative 1/4, that's 3 feet?
Right. So this is over the 3 feet, this is over 9 feet for 12 total. So where do I stand to create the maximum shear at C? But I stand just to the right of 3 feet. If I stand just to the left of 3 feet, it's negative 1/4. If I stand just to the right, it's 3/4. So again, let's say I weigh 1,000 pounds. What's the shear? What's the maximum shear at C? 3/4 of 1,000, 750 pounds. Any questions about that one? All right, that took about 8 minutes to do. Do you have a question? Oh.